In this question it is given that two metal rods 1 and 2 of same length have same temperature difference between their ends. Their thermal conductivity are K1 and K2 and cross-sectional area A1 and A2 respectively. The rate of heat conduction in one is 4 times, in first one is 4 times that in 2. Then our aim is to find out the relation between them. So in question it is given that two metal rods 1 and 2 of same length. So we can take it as their length is same. So length is a constant parameter. Have same temperature difference. So delta T is also a constant parameter. And their conductivities are different. For first one we can take it as K1 and for second one it is K2. And cross-sectional area is also different, A1 and A2. And if rate of heat conduction in the first case is 4 times that in second case, that means we can write the value of dq divided by dt in the first situation is 4 times as that of dq by dt in the second situation. Means if you are taking dq by dt in second situation is 1, then in the first situation it is 4. So our aim is to find out the relation between conductivity and area. So we can use this equation, dq divided by dt is equal to Ka delta T divided by L. Now according to this question, L is a constant, delta T is a constant, so we can write the value of dq divided by dt is equal to a K and A, or is directly proportional to K and A. So as dq by dt is directly proportional to K and A, so that means dq by dt in the second situation divided by dq by dt in the first situation will be equal to, we can take it as conductivity in second situation and area in second situation divided by conductivity in first situation by area in the first situation. So we can write this is equal to this dq by dt in the second situation is given as like 1. If dq by dt in the first situation is 4, so we can write this 1 by 4 is equal to K2A2 divided by K1A1. So we can write this K1A1 as equal to nothing but K2A2 is 4 times of K2A2. So that will be the relation between area and conductivity.